Okay, so we have to start on time. So welcome to the software engineering tutorial session. I believe you are the students from e-commerce program. Um, so now I have shared my screen, as you can see. I'm going to turn off my camera because you can save you some bandwidth and you can concentrate on the slides, okay? So yeah, I turned off my camera. Now it's just my voice and the slides. Uh, I can see all your messages on the chat box. So if you have any questions at any time, you can tap in there. And by default, your audio is not enabled for everybody. If you want to talk, there's a raise hand button at the bottom of the screen. Click that and I can enable each individual student's microphone so you can talk. All right, so let's get started. So the whole point of today's tutorial is to help you, okay, go through the week 1 teaching material. As we say, it's quite different this year. We don't have the chance to see each other. So as a lecturer, we made all the lectures as a video recording. But I totally understand there's different from what we see in the classroom. I hope before you join this session, you have already watched all the videos and you have gone through all the lecture notes and already finished the exercise. So the exercise, let's go through it and let's make this kind of revision, see what we have learned from the whole week 1 teaching. So the first topic we discussed in our lecture is about software and software engineering. That topic was probably straightforward. You can see the first question I ask you to complete is to draw a concept map. So here again, let's talk about why that is important. As you can see, software engineering is kind of a module with a lot of theory and practice. So in order to build high level, high quality software, you need to understand those fundamental theory and you need to be able to apply the theory in later practice. So later on, once we start our lab and group project, it's all about building your software product, right? So how do you get started? To apply this knowledge is very important. So concept map is a very important and very useful tool for you to put all the knowledge together. So by forming a concept map by yourself, you can test yourself whether you have understood all the concept and their relationships. Because you're from e-commerce students, I think Bindu in her law module, she also introduced such a thing. Maybe it's called mind map or conceptual diagram or something else, but basically it's the same principle. You need to understand, okay, what are the new concepts I have learned from this lecture, and can you put them all together? So looking at the map will greatly help you. So you can see for the first example, I've already given you everything. I showed you all the concept which we can identify from the lecture notes. And this is an example I provided for the first exercise. So you can see, let's go through this quickly. So this can be used as a review for the lecture 1 notes. So for the lecture 1, we talk about two important concepts. One is software, the other is software engineering. Okay, you can see my mouse circulate the concept, right? So the most important two concepts, software and software engineering. So focus on software first. We mentioned software is not just code, right? It's not only code only, otherwise it's just the code programs. So programs are the most important component of software, but software also include other things, right? So computer software is important component of the software, but software also including like documentation, data, etc. So I didn't put it in this diagram, but in your version, you could also put those down. So software have to run on top of the hardware, and there are two type of the software products, generic or customer, and we will see the questions about particularly refer to that. And you can see we can classify the software in another point of view. System software, which refer mostly like operating system, utilities, and application software need to run on top of the system software. So mostly we're talking about the software product, they are application software. And there are different types as well, like web-based, cloud-based, phone app, standalone, right? So this show you an example. In your own version, you could add a lot more than that. So why do we need a software engineering? Because it gives you a systematic approach, right? Systematic approach to guide you to build high quality software. That's the need of the software engineering. So software engineering is a layered process. If you still remember the diagram, we say fundamentally we need to choose a process, and then we need to choose the method, and on top of that, we need the tools to support it, right? So software failure always happening, right? You can see on the QM Plus website, we provide a lot of failure example. One is most recent in just last week, the Heathrow Airport IT failure again. So yeah, you can see the failure could be large scale, which lots of impact, could be small scale as well. Okay, so following this diagram, we can see this is a summary about the first lecture. Okay, now down to answering this particular question. Okay, generic software and custom software are the basic two types of the software products. However, the distinction between the two types of the software product is becoming increasingly blurred. Okay, so here we're using a word called blurred, which means no clear cut. It's no black and white, right? We can say, oh, this is a customer software. This is generic software. There's no clear cut on that. So why are we saying that? Okay, so this question is actually a real exam question on the past exam paper. So it asks you to explain the statement with an example. Okay, I think this question should be straightforward. Does anyone want to post your own solutions to the box, and I can give you some feedback if anyone want to do so. Okay, I can see 43 students here. Does anyone want to post your own solutions so I can give you more specific feedback? You can do a simply copy and paste onto the chat box. Right. Okay, I'll wait for another few seconds. If no one, we continue. Okay, so here I will show you two example answers. As you can see, there are different ways to answer this question. Okay, if you see this on the real exam paper as well, it's no absolutely answer. We can show you two different answers. They both good, right? If you have them, they both get 4 marks. So on this slide, you can see, yeah, the question is asking you two things. One is to explain the statement. Second is to give an example. Okay, you remember you have to read the questions carefully and understand. So these two are, I mean, if we see this kind of answer on the exam paper, they both got 4 marks. Let's look at the example answer 1. Okay, so to explain why this kind of definition is getting blurred, you can say software companies are starting with a generic system and customizing it to the needs of a particular customer, right? As we mentioned before, for the purpose of reuse, right? For purpose of scalability. When the software company start making a product, it can be generic, right? So every kind of customer in this industry should be able to use that. So here you can see, give a very good example. This is already the example we mentioned in the lecture recording. So Moodle is a generic learning platform, like a virtual learning environment. So almost all the UK universities use a Moodle-based system. However, every single university can customize it to fit its own needs. Like in Queen Mary, we call it QM+. Okay, we customize a lot of different modules to fit to Queen Mary's use. So I know like in UCL, they have UCL Moodle, King's College as well. All the UK university are almost using the Moodle-based generic platform, but customized to its own need. So the second also is a good example. It's explained in a different way, but the same meaning. Software products are delivered as a standard software and can be adjusted to specific need to the customer, right? Here, give another example, right? It's the enterprise management system called SAP. So a lot of big firms are using this kind of system to manage their company, but every company has their customized version for that. Okay, so you can see these two answers are completely different, but both of them are good. I hope you have done this yourself and you did something differently. Okay, I really want to see something differently. For example, you can see like the online teaching platform now. We use a lot of online teaching platform. Like here, we're using the Collaborate. In China, I believe we use something different. Okay, so those kind of online teaching platform has a really high demanding now. It's a good chance at the moment for them to develop. So they could develop a generic platform for the online teaching, but for each different school, universities, they can customize to its own needs, right? So this could be another very good answer to this question. Now let's move on to the topic about software processes. Okay, again, the first question is to help you to put everything together, to draw a concept map. This time, okay, I give you all the concepts. So all you need to do is to shift them around and add the relationship and put them as a whole picture. If you can do it, which means you have a good understanding about this topic, right? So you can see we gradually move on. At the beginning, I give you full solution. Then the second one, I only give you the concept and you do the map. And later on, I will not help you anymore. You have to have your own habit, okay? After each topic, the first thing you need to do is to draw a concept map. That's to test yourself whether you have a good understanding of all the concepts. So this question is particularly, I think, it should be easier because I've already given you all the concepts. So you should have your own version of your concept map. And let's see an example I give, okay? Can you see the words clearly? It's a bit small. Can you tell me, do I need to zoom in a little bit? Is it too small? Too small, okay. Okay, let's zoom in. But zoom in, we can't see the whole picture. We can work on different sections, okay? Is this okay? Is this size okay? Oh, need bigger? Is this okay? Okay. So we can zoom in out for the different sections to focus on that. Okay. Right. I will try to make it a bit bigger when we talk about different sections. Okay, so let's make a little bit bigger now to focus on the software process, focus on this part. So for this part, first of all, is a software process. How did we get started? If you still remember the lecture recording, okay? When we talk about software process, we first talk about all the activities. There are generic activities in every type of the software process. So requirement specification, design, implementation, testing, okay, also analysis, you can shift it around, okay? So normally follow this sequence, requirement, analysis, design, implementation, and testing, okay? So each of them is an activity in the software process. So implementation also including programming, which you build your code, and debugging, which you find the errors, okay? Right, so that is that part. We talk about different processes, okay? Let's move on to on the right hand side a little bit. So we know for each of the software process, these are generic activities. How can we make sure we have different software process model, right? So first of all, what is software process model? Process model is just the abstract representation of the software process. You can see the major two concepts are here. The model is an abstract representation of a particular process. Why they are different? Because they organize the activities in a different way. We can see they can be strictly follow a sequence, which become a waterfall model. It can be concurrent or overlapping, that's evolutionary development, following focus on the incremental development. And rational unified process, which is quite successful and has been using for many years in the industry. It's a kind of trying to make everything generic. And now everybody talking about agile, okay? So these are the 4 different software process models we talked about in the lecture. And they are different because they organize all the activities in a different way, right? As a summary, waterfall, all of them in the sequence, evolutionary in a kind of concurrent way. Rational unified process, we can see in phases, okay? Phase 1, 2, 3, 4. Inception, elaboration, construction, and the transition. So if you go back to the diagram of the rational unified process, you can tell that in each phase, we have different kind of activities. But as we say, at the early stage, like the inception, more focus on the requirement. Move on to the elaboration, more focus on the analysis, design. Construction stage, more focus on the coding, etc. So why we say rational unified process is generic, because you can adjust the activities in different phases to fit to your own needs, right? That's why the whole software industry trying to make something generic. As we say, what we focus on agile at the moment. In the recent like 10 years, agile perhaps is the main development process we have to follow, because the current business environment requires like a rapid development. So agile is the process to fit to this needs. So let me just make this a bit smaller so you can see the whole picture, right? This is the whole picture of the concept map, trying to put the concept you learned from the software process classes all together. I do hope you have your own version of the concept map, because the concept map is to show your understanding. This one is to show my understanding, not your understanding. Okay, you need to do something on your own version, right? So okay, so we can move on if everybody is fine with this concept map. If you didn't see it clear, don't too much, and we will publish the notes on the QM Plus, and also you can see this is recorded. You can see later on. Okay, so let's make it a bit smaller so we can see the whole page. Okay, now let's move on to the next question. Let me put it to fit to page level. Yeah. So now the next question. Me back to the concept map. Yeah. Okay. So the next question is, suggest the most appropriate software process that might be used as a basis for developing a system to control anti-lock braking in a car. Give your reasons. Okay. Does anyone want to put down your answer? Which model you think is the best here? You can simply type in waterfall. Yeah. I can see Zehua Chen put on waterfall. Yes. Anyone else has other opinions? Yeah, waterfall as well. Yeah. Wen Kai said waterfall. Yeah. Yijun said waterfall as well. For safety. Yes. Yeah. Yuefeng said for safety reason. Okay, very good. I think you understand. So we can see in the lecture we discussed the difference between different process model, and we also discussed the advantage and the problems for each kind of process. So the important thing is, if I give you a scenario for any kind of scenario, okay, you need to choose the best process for developing this kind of application. So for this particular scenario, as we say, anti-lock braking system in a car, the safety is the most important thing, okay? As we say, for safety is a kind of non-functional requirement, but it's more critical than the other functions. Without having the requirement safety, every other things is just useless. So for the safety reason, okay, let me just turn, yeah. So we say a waterfall model is the most appropriate process for this scenario. That's because this system, safety is a critical system. So safety is the top priority requirement for this system. In this case, we require a lot of upfront analysis. We need to understand that this is really well before we move on to the implementation. So waterfall model, of course, is the best process we can choose for this kind of system. Okay, so now let's lead on to another question. If I say, okay, in the current situation, a lot of companies are starting to developing the online streaming, online lecturing platform, okay, which kind of process is the best for that? Agile, yes, perfect. Yeah. Why do we need Agile? Because the requirement is not clear, and we have the highly pressure. We need the speed. Yeah, we need the speed to deliver, to make the product work. So it's not possible to get everything ready, right, at one go. In 2 days, maybe we have to have the online lecturing system delivered. In another, maybe one day, we have to have the the online exam system working, right? So the requirement is not clear, so we have to develop on the go, and we really need to hurry up, right? So the development time is in days or even hours. Perfect. Yeah, that's it. For the whole point of the process, you need to understand the advantage and the problems of each one, and you need to be able to choose the most appropriate process for each kind of different scenario. Now let's move on to Agile itself. Yeah, you can see I gradually, I don't provide the concept for you at all. You have to define, to circle down the concept yourself through the lecture notes and through what you're reading, okay? So here I could show you a few concepts you can identify through the lecture notes. Like we talk about iteration, we talk about TDD, extreme programming, pair programming, refactoring, okay? So those terms, when we move on, perhaps something new to you, okay? So if we look at this concept, what is refactoring? What is extreme programming? What is TDD? What is a story card? Okay, so that perhaps some new terms for you. They are not more generic. You can see from our everyday daily life. It's more professional terms used in particular in Agile. Okay, so then as we see, it's important you need to understand each term and you need to understand their relationship. So let's make a simple diagram like that. Again, here you can see the whole picture, but I can zoom in a little bit to see more clear in different sections. Okay, so this concept map is about Agile process. So we put Agile in the center here, right? So why do we need Agile? Because the pressure for the rapid software development. So Agile is a particular process for rapid software development. So let's put in all the concepts together. Iteration, okay? Now I help you to review Agile. Let's go through each concept again. Iteration, as we say, Agile's process is concurrent. Agile relies on iteration. So if you refer to the diagram in the last lecture notes, there are different circles, right? From one circle, move on to the other. Each circle we say is an iteration. Each iteration is typically 2 weeks. So it is a release cycle of the software product. So for in each iteration, we have planning, we have requirement analysis, design, and evaluation to make a final product, right? So by the end of each iteration, you have to deliver a working version of the software. In the next iteration is another version with added on features or fixing bugs, etc. So Agile relies on the small and frequent release based on iterations. That is the iteration. TDD, test-driven development. So TDD, extreme programming, these are all kind of method, or we say practice in Agile. Yeah, I remember in the message board, it's a very good question asking what's the difference between Agile and evolutionary development or incremental development. We have to say Agile is not a single thing. Agile is a set of good practice, okay? The key thing is Agile collect those good practice together. But to develop a certain product, you don't have to use all the practices. You choose those best fit to your project. Test-driven development is the most widely used method, I would say, practice in Agile. Almost all Agile projects using test-driven development because for the speed, for the purpose of speed, right? So we write the test code before the actual production code, and the test code is all automatic. Whenever we develop something, we run the test immediately, right? So that is the purpose. So TDD, test-driven development, is a method in Agile and is widely used. Move on, extreme programming. Similar, extreme programming is also widely used. Extreme programming is we take this to a extreme approach. Several versions could occur in a day, right? And pair programming is the feature to achieve extreme programming. And other things we mentioned, story card, because in Agile, we write the story, we express the story, we express the requirement as user story. We use we write the user story on the story card. So it's the form of expression for the requirements in the agile way. And we put all the story cards in the wall, which is to help us to understand the iterations and the priorities. So story wall contains all the story card, right? So in agile, we highly need the end users engagement because agile relies on the rapid feedback from end users, and agile's focus is on delivery of the working software. So agile focuses on code refactoring, right? We briefly mentioned refactoring is continually to improve your existing code, right? At the first version, you write down your code like might work, but may not be in the best form. You can find a better way to simplify your code, things like that. We will look at a lot of examples once we're talking about TDD in this particular lecture in the next teaching week. Okay, so again, here I give you the overview of the picture, and yes, you should have your own version of that to show your own understanding. So let's move on to this question. This question should be straightforward. Okay, describe pair programming and discuss the advantages of pair programming. Okay, so this is quite straightforward. You can find the answer from the slides straight away. So I just put it down something here. So describe pair programming. What is pair programming? As we can see, this is a kind of model answer. You can write it in different way, right? So pair, which means two programmers, really two programmers sitting together to develop the code, right? Pair programming is very typical in agile environment. So if you go to any kind of agile company, you will see they are paired, and the pair programming is the daily practice. I believe we discussed in our lecture, say why we use programming. You probably think why don't we ask each individual to write the code, and the productivity will be as twice as the two of them working together. However, I say no, according to the research, the productivity is pretty much the same. However, there are a lot of advantage of using pair programming. For example, as we say, Agile focuses on the small team. If you do pair programming, which ensure the common ownership, okay? So both of you understand the code standard, right? You understand what you're doing. And two persons' knowledge is anyways better than just from one person. So you can share your knowledge across the team. Also, it serves kind of informal review. So when you write the code together, it's easily to spot any problem. It's easily to find out alternative solutions, right? And encourage refactorings. You can keep improving the coding, simplify your code, and the whole team can benefit from that. Okay? Right, let's move on if you're okay with this question. I can see somebody is typing. Junyan Shen, do you have any questions regarding this one? Okay, so let's just move on to the next question. Right, so Agile is a process with a lot of benefit. Okay, we can make sure delivery fast. We can make sure we meet the requirements because customer involved. I think that a lot of advantage of using Agile, especially nowadays in the unstable business requirement. Okay, however, Agile doesn't fit everything. Okay, go back to the Agile principles, Agile manifesto. You can understand some project because there are external constraints. Agile may not be the one to fit to that. So let's talk about each of the scenario. Let's see if Agile is a good choice for this kind of situation. So for a project, let's look at the number one now. for a project, if it is not possible to get rapid feedback from the customer, right? Will Agile be successful? Yes or no? No, of course, yeah. So we talk about very clearly, Agile relies on the customer feedback. While we have iterations, at the end of every iteration is a working product, and the user must use that and give you feedback, right? So we rely on this feedback and to improve for our next iteration. So if in this situation you don't get customer feedback, Agile is not an ideal process. Let's move on to number 2. The system can be developed with a small co-located team who can communicate informally. Yeah, is this good? Yes, of course, yes. This is a requirement of Agile. You have to sit down together, working together as a team. Communication is the key. Everybody understanding what's going on. Everybody share the ownership of the code. Let's move on to number 3. Okay, so this particular product is a long lifetime system, requires more design documentation and require communication between the original intentions to developers to the support team. You can see the keywords is it's a long life system, require a lot of design documentation. Will Agile be ideal for this situation? No, yeah, I can see a lot of answer. No, that's great. That shows you understand that. So Agile, as we say, is good for the short term, right? Short lifetime system and interactive system. So this is a long term, which means you have to change over from different team, from development team to maintenance team, support team as well. So a lot of documentation has to be produced in order to hand over things. So Agile may not be the right process for that. Rational unified process may be better in this case. Okay, so number 4, the development team is distributed for, or if part of the development team is being outsourced. What do you think? No, no. Okay, actually, yeah, I would say there's no absolute answer for that particular question. I would say no initially, right? Because Agile require the communication, require easy communication. So it's ideal if all the team members are sitting together. However, as we can see, nowadays with the development of the communication software, and also like with the 5G is coming, this may not be a huge problem in the future, as we can see. Even if the team members are in different locations, if they can communicate easily, as if they can sit in the same table, that won't affect it too much. Actually, a lot of Agile team nowadays relies on the remote communication, right? Communication is still the key, but we have technology to support the communication, right? So for this question, yeah, we can't say absolutely yes or no, but as long as your team can still make a good communication, that is fine, okay? So I wouldn't say a firm no to this particular scenario. So let's look at number 5. A system has to be approved by an external regulator, right? So this give you an example. So for aircraft operating system have to be approved by the FAA. So for certain kind of software product, this have to be approved by the external regulator. Well, this situation, I mean, will Agile is suitable for this kind of situation, and why? Okay, this question maybe not straightforward. Again, I would say, I mean, initially I would say no, right? The thing also depending on the regulator, right? So if you understand how the regulator approve things, how you have to prepare the documents, you have to submit a lot of documents, you have to make sure, okay, what you have done, meet the regulator's requirements, right? So this can be done, I mean, through a lot of documentation and through a lot of stages. So you submit your application, the regulator has to arrange their own panel meeting and maybe a lot of meetings, and then finally give you a decision approved or not. So first of all, it will need to prepare a lot of documents. Second, it may take a long time to get it approved, right? So Agile may not be the best choice. So in the next slide, yeah, I put down some answers, but don't take it as an absolute answer. So for the first one, not possible to get custom feedback. We say, yeah, custom feedback is important. So Agile is not ideal for this situation. Number two, as we say, yeah, it's an ideal situation. Number three, no, because Agile focus on the working software. Too many documents or too much time spending on that is not ideal. Number four, as I mentioned, depends. We should put a depends here. If the team are distributed and the communication is very difficult, no. Okay. However, even if they are distributed, but they can make efficient communication with the technology support, even if they are in different countries, different time zones, but they can do pair programming together with the same online system, that is fine. That's not a big problem, okay? So this question, I would rather say it depends on the situation, if the communication is easier or not. So the number five typically is a no, because to get things approved by the external regulators, we need to prepare a lot of documents, and it may take a long time because this is not under your control. It's the control of by the regulator, how much time they need to get it approved, right? So in this case, I would say Agile may not be an ideal situation. Okay, let's move on to the requirements. Requirements. Yeah, again, the first one is to do a concept map. I will go through quickly, okay, this time, because we only have 15 minutes left, and you can look at this later on by yourself. So let's have a very quick look on the requirement concept map. Just use this as a overview, okay? So the center is the requirements. Who provide the requirements, as I say, stakeholders. Okay, who are the stakeholders? Anybody involved in the project, like customer, technology provider, management team, they all stakeholders, they all provide requirements. So requirements in general can be divided as functional or non-functional, right? Functional is more about the service, the features of the system. Non-functional requirements is more about the constraint, like the speed and the user experience, things like that. So it's more about the constraint. So non-functional requirement can be further classified into product requirements, organizational requirements, external requirements. And in the lecture, we give you examples from each category, right? To write a good non-functional requirements, we need to be able to measure the requirements. So quantitative is to give you a number or something to measure that. And fact-finding techniques use those techniques to help you to gather requirements. And we can use prototype to get you the rapid feedback. And we talked about 5 different fact-finding techniques, right? Background reading is for you to understand more about the organization or the company. It's help you to identify rules, different rules. How many rules are different? How many different users are going to use the system, and how they use this differently, right? Interview and the questionnaire is similar for you to get the requirement from the end user. Interview is more like a one-to-one or one-to small group will be more useful. Questionnaire when you need to get a large amount of data quickly. We can also observe some existing system, right? Especially this is important if you want to transform a traditional system to a digital system, right? So think about if we design an online education platform now, observation is very important. You observe, right, in the traditional classroom, what the lecturer and the students do. Now, if we trying to move everything online, we still do that, but do it in a different way. So if we are going to develop any online education system, observation is very, very important technique, right? For you to understand what we need to do, but how to do it in the online form. So document sampling, again, we can help you to understand how to develop the digital system, like how the coursework has been distributed, how the coursework will be marked, right? So this kind of document sampling can also help you. So as a quick summary, this is the overall picture of the requirement for you to understand. Okay, a separate diagram talking about Agile because it's too big, I can't put them all together. Requirement in Agile, right? So the focus here is the Agile. Agile express the requirement in the form of user stories, right? So requirement expressed as user stories. So customer choose the story. Customer prioritize story at each iteration. Development team break down into manageable pieces to write the code for that. Product backlog is the collection of the user stories. However, you have to give the priority of each user story so they become product backlog. For the user stories, we need to prioritize them. Moscow rule is a very quite useful tool. What you must have, should have, could have, or would have, right? So give you an indication of the importance of each story. And we need to estimate how big the story is. We can use small, medium, large, or we can use like using the real hours, right? But more commonly, we're using story points, right? Story points, again, if you remember in the lecture, we talk about it's not in a sequence, it's using the Fibonacci sequence. So 1, 2, 3, 5, 8, because when the story gets bigger, the uncertainty is getting higher. So we need to add more points to that. So if the story has a lot more points, say more than 13 or even 21, we should consider breaking it down into smaller ones, because what's the whole point is you can transfer the story into working code. Okay, so if the story is too big, we call it epics, and the stories are written on the story card, and the story card can be placed on the wall. Yeah, this is a very quick overview of the requirements in Agile. Let's move on. Okay, so now is for you to practice, right? How do you write stories? Right? This is a starting point for Agile project. Writing story is the first thing you need to do. After using the fact-finding techniques, right? You interview with other people, you do the questionnaire, observation, etc. Now it's time to start writing down all the stories to form your product backlog. So this is a typical example which happening in your daily life, right? You withdraw cash from the ATM machine. So let's see how can you write it down in the way as precise as possible, as full as possible, and make sure everybody understand that. Okay, I'm sure everybody have your own experience on how to withdraw cash from ATM machine. This is just a typical example. You can write on the story card. Okay, so if you don't know how to write a story, we say using as a, I want to, so that is a guideline for you to get started, but you don't have to follow that format. So for this example, we say who is going to withdraw money from the ATM machine is a customer. So as a customer, right, then you start to describe the procedure, the sequence, the operations you do to get your cash from the ATM machine. So check every single step. Every single step is important because every single step will be modeled in the software function, right? Every single step will be a function. And make sure you don't miss anything important. So first of all, you insert your card into the machine, right? And you should be prompted to enter the PIN number through a keypad. If the PIN number is correct, you will be shown a menu of options. The options normally have, you can see check balance, withdraw money, or transfer money to other account, etc. Typically, you will see something like that. And the withdraw cash option is one of the options, right? What you need to do is to select withdraw cash option, then you should be promoted to another menu, see how much you want to withdraw, and you need to enter the amount of money, of the cash you want to withdraw, for example, 100, right? So once you enter the amount, the system should check whether you have sufficient money, funds in the account. Yeah, if yes, the cash will be delivered to you through the machine. A receipt can be chosen to print out or not, okay? And your card should be returned to you. And depends on the ATM machine. I know the machine in the UK, they always return you the card first and then give you the money because they don't want you to forget taking the card. But my experience in China is that you get the cash first, then at the end you get your card returned, right? So in this case, don't forget to take your card after you get your money. So anyway, so this is the kind of story we should write down. Again, as we emphasized many times in our lecture, what you have written down on the card as a story is not that important, okay? The whole point here is you can lead to a discussion. So this is the initial stories, right? How do we implement the withdraw cash function in our code? It will lead to discussion, right? For example, you enter your PIN in the keypad, right? It can lead to a lot of different discussion. For example, how many digits is the PIN? Is the PIN only digit or is a combination of digit and letters, right? What is the layout of the keypad? And what happens if you enter a wrong PIN, right? And what happens if you don't have enough money in your account, right? So yeah, this will serve as a basic point, but lead to a discussion. It's a lot of details for the whole team to discuss. Right? I hope you get that. So the story is more important to lead to the future discussion. Okay, the next question. Right, the software should be portable, right? So this kind of a requirement. So the first question is it a functional requirement or non-functional requirement? Is any problems on that? So can anyone tell me, is it a functional or non-functional requirement? Can anyone answer? The software should be portable. It is functional requirement or non-functional requirement? So let's say function is about the service. Non-functional is about the constraint. Okay, yeah, non-functional requirement. I already say yes, great, yes. It's definitely a non-functional requirement because it's not about the service that should provide, but kind of constraint. The software should be portable. Okay, so you can see portable is the feature of the software, and the key thing to answer this question is you understand what does portable mean, right? So portable basically means the system can run on different platforms. I believe I mentioned this in our lecture. So portable means you can run in the different platforms. So the software should be portable is a non-functional requirement. However, this way we didn't provide a good writing of the non-functional requirement because it cannot be verified. Okay, so how do you determine is it portable or not? We need to bring some numbers. Okay, make sure it can be verified so we can see this meet the requirements or not. So if we look at the possible answer, right? So first of all, of course, it is a non-functional requirement. And the problem is that it's not verifiable. So how to rewrite this one? We have different ways to rewrite it, okay? As long as you have a numbers, you can verify that with the number. It can be measured, that is fine. So you can write, the software should be able to run on 3 different operating systems. Fine, you can see 3 is a measure, okay? We can see later on if meets the requirement by verifying is this able to run on 3 different operating systems. Okay, another way to write that, you can say it should be able to run on 90% of the operating system in the market. Okay, it's plenty of different operating systems in the market. If you can run on 90% of them, fine. Okay, 90% is a number, can be verified. Or you can be very specific. Okay, the software should be able to run on both Mac OS and Windows. All right, this is more specific. So now it's become verifiable on the 2 different systems. So all of the 3 answers are good ones, as long as it can be measured, as long as we can verify it later. So the last question, right? What is a sprint in Scrum? Okay, I hope this question didn't bring too much confusion to you, right? So again, let's talk about what is a Scrum and what's the difference between the Scrum and Agile. So Agile is a collection of good practices, as I mentioned, okay? So Scrum is one of that. So Scrum is the one of the mostly widely used Agile practice. So when we talk about Scrum, we use the term sprint. The sprint is actually the same meaning as what we talk about in Agile, which is iteration. Okay, so you can say sprint is a special term used in Scrum, which is to refer to the small release cycle, but it's the same meaning as the iteration in Agile. Okay, so Scrum is one of the most widely used practice in Agile. Sprint is the small release cycle. This is a term used in Scrum. So to answer this question, we could say a sprint is the fixed length, typically 2 weeks, right? Or you can use in the term iteration as well, that corresponds to the development of release of the system. So each sprint, at the end of each sprint, you need to produce a working version of the software, then move on to the next sprint, right? So sprint and the relationship between sprint and the Scrum is the same as the iteration and Agile, but just using different terms. Okay, I think that's all, and we're right on time. Do you have any more other questions, and what do you feel about the tutorial? Is it useful? Okay, let me see. Settings. Okay, so that's the end of the tutorial. I hope everybody got something from that. So I'm going to stop it very soon. Okay. Say thank you. Thank you for attending the session. And yeah, I hope to talk to you soon, right? Okay, you may leave the session easily and okay, bye.